Hello everyone, welcome to this video. This is part 2 about learning about convolutional neural networks, also known as CNNs. So in the previous video, we talked about how in our initial understanding of a CNN, we have kernels, which can be thought of as like feature extractors. In early layers, we extract really basic features like lines, a dot, and semicircles to generate feature maps. And then as the layers progress, there is more complex feature extraction, such as now we have a triangle nose kernel and a eye kernel, and these will also generate feature maps. Now, we are working with nonlinear data because images are not linear, and activation functions can learn nonlinear data. So let's use the ReLU activation function. Here's the feature map, and if you'll remember, a ReLU activation function will keep positive numbers the same, but turn all negative numbers to 0. So here is a ReLU feature map. And now this is our new understanding of what happens in a CNN. Convolution plus ReLU, convolution plus ReLU. Next up is max pooling, where we keep the max number from a 2 by 2 kernel with a stride of 2. This is fairly easy to understand here. In all these like subsections with 4 small squares each, the biggest number is 9. So we'll keep 9 from all of them. So we end up with this 999. We went from a size of 4 by 4 to 2 by 2. So how is this useful? Why should we care? Well, imagine we have this image of a 6, where the number 255 is like a gray color and 0 is like a white color. After max pooling, the size went from 20 by 16 to 10 by 8, and the 6 is very much recognizable. So think of max pooling as compression that still keeps important information. In this case, well, the 6 is still recognizable despite the compression. In a CNN, max pooling is used to compress the feature maps, and unlike perceptrons and kernels, max pooling does not have weights to optimize during training. It only keeps the max number. So what are the upsides of max pooling? Number 1, think of max pooling as compression that still keeps important information, so it reduces overfitting. 2, compressed feature maps means less computation, so you save money and time. Number 3, it helps the model recognize something regardless of location. In this case, when the face is in the upper left-hand corner and the bottom right-hand corner. So here's our new understanding of a CNN. Kernels/weights, or kernels which are weights, learn and extract features, which generates feature maps. Use ReLU on the feature maps so that we learn nonlinear data. Use max pooling on the feature maps for compression. And now to expand our knowledge of a CNN even more, everything we learned about in the previous slide is used to learn and extract features. Then we pass those features to a fully connected feed-forward neural network, which we've gone over previously in this course. So you should have an understanding of what's happening here. And hopefully, this will have really good weights and correctly guess that this is a picture of a face and not a hand or a leg. So in the classification part, we flatten the feature maps, pass the flattened feature maps to the FCFFNN, and the FCFFNN uses the flattened feature maps to classify the image. So despite how complex this diagram has become, at the end of the day, this is all that's really happening behind the scenes. We're just trying to have the best weight values possible, excuse me, so that we have the best outputs or best predictions, etc. Now, the features from learn and extract features right here can be used for other tasks, such as image captioning. We're not just limited to classification. We can chop this part off, so to speak, and use the extracted features for whatever we want. The most obvious, of course, being image captioning. And in the next video, we will run our very own CNN where at the end of the learn and extract features part, we will have 128 pooled feature maps. We'll flatten it out, and the hidden layer of this fully connected feed-forward neural network will have 256 perceptrons, and the output layer will have 10 perceptrons. I will see you all in the next video.